Hello everyone, welcome back to my channel. In my today's video we shall learn how to calculate the spin only magnetic moment. So the very fine formula is mu is equals to square root of n into n plus 2. This is a formula you need to use if you want to calculate the spin only magnetic moment. Here mu stands for the magnetic moment and n stands for the number of unpaired electrons. So let me solve the two questions. So by solving the two questions, you will be able to solve the all other questions. So the first question is Mn2 plus. So we know that what is the atomic number of Magnus? It is 25. And the electronic configuration is organ 3d5 4s2. So this is an electronic configuration of manganese. Here they have asked Mn2 plus. So what is the electronic configuration of Mn2 plus means organ 3d5 4s0. So now for 3d5 you need to write the configuration, like you need to arrange the electrons. So like this 1, 2, 3, 4 and 5. So I have just made the 5 electrons, I have just filled it. So now we know that n stands for the number of unpaired electrons. Here how many unpaired electrons are there? 1, 2, 3, 4 and 5. So there is a 5 unpaired electrons. So using this formula, that is mu is equal to square root of n into n plus 2. So we know that n is equals to 5. So we know that mu is equals to square root of n into n plus 2. So how do you write? Square root of 5 into 5 plus 2, that is 7. You will get 35. Square root of 35. So let's keep the square root of 35 like that only, and we shall just move to the second question. So the second question is Fe2 plus. So we know that the atomic number of Fe2 plus is 26 and the electronic configuration of iron is organ 3d6 4s2. So Fe2 plus electronic configuration is organ 3d6 4s0. So now we have to fill the electrons, that is 1, 2, 3, 4, 5 and 6. So how many unpaired electrons are there? There are actually 4 unpaired electrons are there, that is n is equals to 4 unpaired electrons are there. So now using the formula mu is equal to square root of n into n plus 2, just write it down. In the place of n you just write it down 4, 4 plus 2 you will get 6, exactly you will get square root of 24. So if calculator is there, you can just easily calculate. In case if calculator is not there, you will be bit it will be time consuming and it will be bit very difficult to calculate all those. So for one of the very important trick I'll tell you, which you can by seeing the value of n, you can just write down what is the magnetic moment of particular for example like Fe2 plus, what is the magnetic moment. Just by seeing the value of n you can just write it down. So the very important trick is, for example, see now if n is equals to 4, see for example now if n is equals to 1 and mu is equals to 1, so the magnetic moment, what will be the magnetic moment? 1.73. You need to keep in your mind those values. If n is equals to 1, magnetic moment will be 1.73. If value of n is 2, magnetic moment will be 2.83. If value of n is 3, that is number of unpaired electrons is 3, the magnetic moment is 3.87. If the number of unpaired electrons is 4, the magnetic moment will be 4.89. If the number of unpaired electrons is 5, it will be magnetic moment will be 5.91. So this table you need to keep in your mind, so that in exam you will not be bit confused how to solve all those. Instead of using calci, it will be very time consuming. So if you just keep in your mind all these values, you can just solve it. So now let's go back to the question. So the first question, what we got for Mn2 plus, what is the n value we got? we got n value as a 5, right? We got n value as a 5. So if the n value is 5, what is the magnetic moment? It is 5.91. Exactly. You will get, you can just cross check my method in the calci also. Square root of 35, you will get exactly 5.91. 5.91 you will get. So what is the magnetic moment of Mn2 plus? It is 5.91. So the next one is Fe2 plus. So if the n value is 4, we got the n value as a 4, that is number of unpaired electrons, we got 4. So if the number of unpaired electrons is 4, what is the value? 4.89. So just write it down as 4.89. You can just cross check in calci also, you will get approximately the same value. I hope you completely understood how to find the magnetic moment and how to calculate the number of unpaired electrons, and this box is very important. You need to keep in your mind, instead of doing the long methods or instead of using the calci, you can just learn this table and you can just do it. So thanks for watching my video, and if you completely like this video, please click the like button and please share to your friends, and if you are new to this channel, please don't forget to subscribe to my channel. Thank you.